share my screen. All right, so in some ways, this talk builds upon what I presented yesterday, which is which is to look at the effects of this information disclosure programs that are intended to encourage firms to self-regulate and then can sometimes have unintended consequences. So this is really a paper that was published this year in the Journal of the Association of Environmental and Resource Economists, and we have a subsequent paper that we are working on. So I'll present at the end some of the findings from the second paper as well to kind of give you a more complete story about what's happening. So, yesterday I talked about these information disclosure programs that are really a strategy being used by regulators to inform stakeholders about the environmental performance of firms in their neighborhood or their community, and thereby empower these stakeholders so they can directly create pressure on firms to improve their performance. And this is a way to get more public participation in regulating firms when it becomes difficult for governments alone to take all the necessary action. One great example of this is the toxic release inventory that was created under this Emergency Planning and Community Right to Know Act in 1986 in the US after the Bhopal gas leak by Union Carbide in India. And it was felt that it would be better to provide information to the public that is located next to these toxic releasing facilities so that they can be better prepared, they can take action to make sure that firms are being responsible. And so under this TRI, all manufacturing facilities in the US that are emitting toxic chemicals above a threshold level are required by law to report every year their toxic releases by chemical, by how they're disposing it, what methods they're using to prevent, treat, recycle, dispose. And, and this is, I think there are like more than 600 chemicals, and it's a very detailed and extensive reporting system. And it is provided by every facility, and this and publicly available. So you can go in and put in your zip code, and you can see all the facilities in your neighborhood that are emitting, what chemicals, what they're doing, what actions they're taking, and so on. And so the US EPA releases this information every, it takes 2 years, but what's going on. And there's a lot of credibility associated with this because it is subject to auditing and penalties and so on. So an advantage of doing this is that toxic releases obviously raise a lot of public concern about health and environmental damages. And the studies have shown that in the neighborhood, with large firms located which are emitting these toxic releases, property values go down. Investors, we were talking yesterday, view these firms with unexpectedly high toxic releases as being at risk for liabilities and regulations in the future and having lower market value. And so these firms have been observed to have lower stock market returns as a result of that. And so all of this is, signals to these firms that they need to do something about their toxic releases. And community members can undertake collective action and lawsuits and boycotts and so on. So all that is as intended, but where it becomes a little bit more unclear is when we know that these community pressures are not going to be uniform for all communities. They're going to depend upon the socioeconomic and the demographic characteristics of the community. Some communities can exert more pressure, they have more bargaining power, and other communities have less. And so, from the firm's perspective, they suffer reputational costs when their names are released to the media, and in fact, these firms make more stronger efforts at trying to reduce these emissions through participating in voluntary programs. And so what's been noticed is that since 1987, actually toxic releases have dropped down, even though they're not directly regulated. Between 87 and 2014, these had gone down by 40%. But the biggest reduction was in the richest counties, and the 68% of the reduction was in the high income counties and only 18% in the poorest counties. And there's also this general anecdotal evidence that the African American communities have been more exposed to toxic releases than others. So there's clearly a lot of spatial disparity in where these toxic releases are being reduced, and to some extent, these appear to be correlated with the characteristics of the communities. So the questions that we are interested in looking at is the extent to which community pressure was effective in leading these toxic release firms to leave their community and move to other destinations. Now, firms could take various actions. They could stay where they are and just reduce their toxic releases, or they could leave and locate themselves in other destinations where the community pressure is lower. And we're looking at the second question of whether or not they move out to other destinations. And then we want to look at which communities do they move to. Are they, in fact, communities with less pressure? Which types of firms are more likely to relocate? And what does the relocation mean? Why are they locating? And what does that mean for their economic and environmental performance? And is there this unintended effect of information disclosure leading to this problem of environmental injustice? Now, one of the challenges in conducting this analysis is the fact that when we're looking at long-term impacts, so where facilities are located or where they relocate to, it is really difficult to separate out the the question of who moved first. Did the community move did the facility move to a low-income community, or did when the facility located, then the rich and the educated white population moved out, and in fact, and the property values declined, and the lower income and blacks and other minorities move into that location. So it's hard to know whether the facility moved first or the low income community moved first, and because households can move. And so there is this problem of reverse causality, and which makes it hard to isolate the effects of the community on the firm behavior. And so previous studies have tried to navigate their way through this problem in a number of different ways. Some of these studies have looked at the effects of a new facility. What causes a new facility to be born or to locate in a community? Do they tend to locate in poor and minority communities? So these studies don't suffer from this reverse causality problem because they never existed before, and the community could not have responded before the facility existed. So and so they get around that problem. Others studies have looked at the effects of environmental regulations at a location in deterring new plants from locating. And so they're not looking at community characteristics, they're looking at the effects of regulations. And some studies looked at how community characteristics can affect the amount of pollution reduction. And they kind of get around this problem by having a spatial lag. So they're not looking at the effects, they're looking at the effects of communities located a distance away from the facility and not in the immediate neighborhood of the facility. So there are a couple of different things that these studies do. In our case, we were interested in looking at the effects of this information disclosure on leading some communities to take stronger action than others and to push these polluting facilities out, cause them to relocate to other communities that were more socially disadvantaged. And there's several reasons why these push factors might operate. They could raise the facility's reputational and legal and other operating costs at the location, affect their, now whether they decide to move will also depend upon the costs of moving and, siting themselves and expanding at a new location. And then we want to examine the effect on these facilities' environmental and economic outcomes and see whether it worsens environmental justice. So related to this, there is quite a bit of a literature which is on something called the pollution haven hypothesis that you all might be familiar with, which is basically examining the question of whether weak environmental regulations in developing countries can cause firms in developed countries to relocate to them, and thereby make these developing countries be like pollution havens that because of their lower, weaker environmental regulations. And most of the studies actually do find that pollution haven hypothesis does not really hold. Firms do not relocate because of environmental regulations. They locate for other reasons because of advantages of labor costs and other factors. But nevertheless, there is that literature. We differ from that literature in that we're not looking at location firstly across countries, and we're also not looking at relocation due to stringency of environmental regulations. Instead, what we are trying to understand here is the relocation due to local community pressure. And although we do control for differences in regulatory stringency across these jurisdictions within the US. So as we think about this relocation, there's why might relocation affect environmental performance, and there's actually no real reason to think that relocation must necessarily improve or worsen environmental performance. It could do either of those, and it depends, one of which is the scale of operation. Facility may decide to become larger. They may change their technology. They'll be affected by the differences in the stringency of regulation, differences in labor costs or land costs, and also differences in community pressure between the moving destinations and the origin locations. And facilities may relocate for various reasons besides community pressure for their toxic releases. They may move because of the lower costs of expanding operations, or easier access to input and output markets, or being closer to other firms that are of a similar industry, and so on. So there's various reasons why relocation can happen. We're interested in looking at one such reason, and while controlling for a number of other factors that one needs to be aware of. And so theoretically, conceptually, there's no reason to believe that relocation is necessarily going to worsen or improve performance, and it'll depend on many different factors that are related to the facility, reasons for moving, as well as the characteristics of the community and the regulations and so on. And when we're looking at the effects of regulation on environmental justice, it's not just that, what happens to the level of emissions of the facility, do they go up or not? But really what is important is what happens to this effect relative to that of other relocating facilities. So it could be that relocating facilities may all be reducing their emissions, but facilities that are relocating to a low-income community may reduce less than others. And so that would be, create this higher exposure in the low-income communities to toxic emissions and cause a problem of environmental injustice. So it's really a question of, looking at relative to other relocating facilities. That is the important factor in trying to prove whether or not there is environmental injustice. So
I think Professor Khanna's connection probably is disturbed a little bit now.
Yeah, we'll just wait for her to sort of.
Yeah, I was wondering whether it's my connection.
Me too. So
I think she'll reconnect. I think we should request her to.
She's connected.
All right.
Keep the video off.
I think I'm connected. Sorry about that. Can you see and hear me now?
Yes. Yes.
Okay.
not your screen.
Okay.
You have to share it again.
Yeah, got it.
maybe we can keep our videos off. That might help us all.
Yeah, actually, if I could try, well, let's see how it goes. If not, I can close my screen as well, and that might help. So, okay, so all right, so we want to look at this causal effect, and we want to control for this reverse causality. And one thing that works in our favor in this analysis is the fact that this public disclosure only started in 1989, late 1989, 1990. Before that, the public did not know where are these toxic release facilities, what are they emitting, so they could not have responded to that. They could not have changed their behavior and decided to relocate themselves before 1990. And so this provides like a natural experiment for us. And we can say that we're going to look at the effects of community characteristics and relocation after looking at the characteristics in 1990 and its effects on relocation after 1990. And so by doing that, we can avoid the problem of reverse causality, because those characteristics of the communities could not have changed in 1990 because they did not know what the toxic releases were. So that's how we get around the reverse causality. And then we want to, we also want to look at another issue, which is that there were many firms that were not reporting their emissions in 1990 because they were below the threshold. But we want to see whether even those firms were affected by community pressure when they were going to grow in the future. So this is sort of an anticipatory effect. When facilities know that they're in the future, they're going to start reporting to TRI, they may act prospectively and move in advance. And we want to see whether that is the case or not. And then we want to look at the characteristics of the destination communities to the origin communities and see whether, in fact, there was a difference as expected. And then lastly, we want to see if the facilities became dirtier or cleaner because of relocation, and how this affected the spatial distribution of pollution incidents and the role that community characteristics played in doing that. And that part of the research is the work that is in progress. So conceptually, as I said, this TRI can cause public concern, and it can lead firms to relocate. And we're assuming that firms are profit maximizing. They're going to relocate by weighing the costs and benefits of staying versus moving to a new destination. And the factors that are going to affect the costs of staying at a given location are, will depend upon the strength of the concerns about toxic releases in the community. So if you're in a community where people are educated and heavily concerned, they're going to put more pressure on the facility to relocate. It'll also depend upon the ethnicity of the community. So where there's a lot of minority, population, or population that is fragmented by race, they are less likely to be able to have the bargaining power that is needed to influence the facility to move. Additionally, facilities that are not very politically well organized and not able to organize themselves to undertake collective action are also more likely to not be able to induce facilities to move. The potential for liability for damages to human health will differ in different locations. So locations where there is high density of population, or where there are a lot of older or young children, those places are more likely to have be able to sue or set up lawsuits against facilities for causing environmental harm. And so facilities may like to avoid those types of locations. And then there are other factors: regulatory pressures, economic conditions like the cost of labor, cost of access to inputs, access to markets. Those are the other factors that will also influence the economic costs of staying at a given location. And so we set up just a simple conceptual framework where the profits shown on the left are a function of the cost of pollution generated that is, that is a cost on the firm because of community pressure. Then there are location-specific economic and regulatory factors that affect the profitability. And then there are facility characteristics such as its size, its pollution level, and so on. So we want to control for all of these factors and look at the impacts. And our basic hypothesis is that a facility will move, and so RIT is the decision to move or not to move, and it's going to L1 or moving to location L1 compared to location L0. So if, minus the cost of moving. So there is a cost of relocating, and the firm is going to factor that in and then decide whether its net benefits or net profits are higher. And we use various variables to try to proxy for these types of 6 pressures that I had mentioned in the previous slide. The strength of community concern, it's going to depend upon things like income level, educational attainment, because that determines access to information and knowledge about the health risks due to toxic releases. We consider ethnicity, or we capture the effects of ethnicity of the community by looking at the share of the minority population, as well as a politically active community, number of voters, what percentage of voters turn out in a election year. The political ideology, the share of Democrats, which are typically more, likely to have more stringent regulations, more supportive of environmental protection than the Republicans. Potential for liability depends on the size of the vulnerable population. Other location-specific characteristics, such as the regulatory pressure. If a county is already in poor environmental condition, it's not attaining its environmental goals, then it's going to create more pressure on new facilities from locating there. But if it's, so the current stringency will depend upon that. Other economic conditions like wage rate, employment rate, availability of labor, number of other toxic facilities, and so on. And then facility characteristics such as their size, their financial health, and their emissions levels. So, so we have, a number of these factors that are defined. So in addition to the characteristics of the community, we have, looking at vulnerability, sort of number of children under the age of 5, number of fraction of population that is elderly, the diversity, racial diversity of the population. We also include whether most of the population is renting or owning their housing. Renters are more of a transient population, and so less likely to be, concerned about pushing facilities out. They may be more fraction of vacant housing. Location characteristics such as things on the internet can affect regulatory, looking at wage rate, high cost of labor can deter facilities or cause them to move away for other reasons. Access to transportation networks like the miles of highways in that census tract, or miles of railways, fraction of urban population, housing value, which determines the cost of land, and so on. We also want to look at whether larger facilities were more likely to move compared to smaller facilities, and then more polluting facilities compared to less polluting facilities. Facilities in better financial health will be more likely to be able to afford the cost of moving, and then also, so we have a pretty large sample of facilities that are, available to us, and then we're looking at this effect over an 11-year period. So the econometric model that we are estimating is, where we're looking at this latent variable, or the likelihood of moving, which is RIT star, as a function of the community characteristics, the location characteristics, and the facility characteristics. And these betas are the variable of most interest to us, which is the effect of these community characteristics on the likelihood of a facility moving. Relocation is defined as a movement from its current location, but some facilities just moved from one census tract to another. Other facilities moved to longer distances, and so we have that information. We can look at what caused movements, to different distances, and we have, as I said, a number of these community characteristics. Some of these are available at the census tract level, so we can use them to explain movement from one census tract to another. But other characteristics, such as the non-attainment status, is only available at a county level. So it cannot explain movements within a county, and we therefore estimate two different types of models. One where we're looking at relocation across census tracts, and another one where we're looking at relocation only across counties. For every facility, we draw a 1 mile circle around that facility, and then we look at the demographic characteristics of the census tract where this facility is located and those of the other census tracts. And we take a weighted average of the community characteristics of all the census tracts within the 1 mile circle of the facility. And that is a measure of the pressure that 1 mile radius community is imposing or able to impose on this facility. And so, that's how we distinguish amount of pressure. Some of these other characteristics are only at the county level because they're not available. And so we measure those at that level. And this just describes the different types of variables that we have. And as I said, we are able to avoid the problem of reverse causality by using the 1990 value of these community characteristics to explain relocations after 1990. So we can safely assume that the demographic characteristics in 1990 are predating the relocation decision of the facilities and can be treated as exogenous. So we estimate two versions of that model that I showed you, the latent variable as a function of the different characteristics. The first model is more of a cross-sectional model, and we are trying to explain a facility's probability of relocation over the next 5, 10, 20 years. So the question we're asking is, did the provision of information in 1990 cause a facility to move over the next 5 years or over the next 10 years or over the next 20 years? So it can take time for facilities to feel the pressure and find the location and shut down operations in one place and move to another place and so on. So it may not be an immediate effect. And this is looking at, we use different time periods to look at where do we find the strongest effect. And the second model that we estimate is more of a panel model where we're looking at the annual probability of relocation due to information that was made available 2 years ago. And so here we're looking at the characteristics in 1990 affecting the relocation probability, and on an annual basis, and based on the characteristics that were there in the previous year. So our sample includes manufacturing facilities that were operating in 1990 and that reported to the TRI at least once between 1988 and 2011. And so facilities often move in and out of reporting to TRI. If they fall below a threshold, then they stop reporting and they start later and so on. So we allow for that. We're looking at everybody who reported at least once and therefore was eligible and could feel this pressure from the communities. We combine the TRI data, which basically just provides information on toxic releases, with another data set which gives us information about the address of the facility over time. And by doing that, we can actually track which facilities moved and from their previous address and their new address, and when they moved, and so on. We also obtained the data, the rest of the data, from various other sources, including the Highway and Transportation Database and data. There is annual, 4 years presidential voting data is available, so we can use that. And then there are other databases from EPA and so on. And basically, in the final sample, we have this is an unbalanced panel. We have about a relocation, about 13% of the facilities moved across locations. So what do we find? Well, the relocation, we find really a significant effect of some factors as expected, and others unexpectedly did not have an impact. So the ones that had the impact were educational attainment. Communities with higher educational attainment were more likely to push facilities out. Facilities also relocated out of communities with higher population density because of potential concerns about liability, and also from counties that were more stringent because they were in non-attainment. So regulatory pressure plays a role. High labor costs and high land costs, lower access to transportation networks due to such as railways, facilities that were in better financial health. And we find that smaller size facilities with fewer number of employees were more likely to move. And so these are very much as expected. Smaller size facilities have lower costs of relocation and startup. And so that is also as expected. What we didn't find was, despite trying a number of different specifications, is that the level of toxic releases did not seem to have as much of an impact, and or actually did not have a significant impact. In some regressions, we found that it was the smallest polluters actually that were more likely to move rather than the largest polluters. So our expectation would have been that facilities that are really the largest polluters are more likely, but that was not the case. And it could be for various reasons. It essentially could be that there's a lot of collinearity between size and releases, and that larger facilities with larger releases may also just have higher costs of relocating. So that could have explained this. Similarly, our panel data analysis shows that we can sort of calculate the effects on the probability of relocating, and this shows that a significant increase in the share of more educated residents increases probability by close to about 1%. And similarly, an increase in population density increases the probability of moving by another, about 1% or so. And this is similar almost in scale to what happens if local labor costs go up. So it kind of gives an idea of the relative magnitude, but in general, the results from the cross-section and the panel data are similar in showing that local community pressure, in particular education, seems to matter. Other things like income, for example, or racial factors did not have an effect. So those were the other surprising outcomes that despite a lot of anecdotal information and concern about the effects of racial injustice, we did not find that to be a significant factor here. Interestingly, we also found that when we looked at whether the firms were responding to TRI reporting in the future, the fact that they would have to start reporting in the future, particularly facilities that were small currently but expecting to grow, might be affected by the anticipation that when they start to report, they will face negative publicity and so on. And so we find that these facilities that were also more likely to relocate. So these are forward-looking facilities that were not currently reporting and and they relocated because they expected that they would grow in the future and therefore have to start reporting that. So when we compare the characteristics of the communities at the destination locations and the origin locations, we find that in fact facilities are, on average, locating into counties with communities with lower income level, lower population density, lower share of Democrats, and so places where the regulations and the political climate would be more favorable to businesses and not to the environment, as well as locations where the counties were more likely to be in attainment and therefore less stringent in terms of their regulation. And that this relocation tendency was stronger for facilities with below threshold emissions. So facilities that are smaller, not even reporting necessarily, were more likely to relocate into these lower education, lower voter turnout communities. And that, in general, they were locating where the score, we created a score for every community in terms of its community pressure, and we found that was one of the main factors in addition to regulatory pressures in causing this relocation. So if we do just a simple comparison of the movers and the non-movers, then we find that in fact the movers had made smaller efforts at reducing their emissions, and that they were also accompanied by an increase in size. So in general, what we found is that facilities were moving because they were likely expected to grow, and they in fact did grow after they moved, and they made smaller reductions in emissions. The emissions per employee were, in general, it seems like the facilities were moving primarily because of this desire to increase scale of production. And because of this increase in scale of production, they also increased their emissions. But we did not find any evidence that they increased their pollution intensity. So it was not as if their pollution per unit employee went up or pollution per unit output went up, but it was just that their total output and total employees went up, and therefore their total pollution went up. So and so these communities were moving into lower pressure locations. Primarily, it seems like because they expected to grow and expected to increase their emissions, and not necessarily because they wanted to move because they wanted to increase their emissions. They moved because they wanted to grow, and the growth led to increase in emissions. And so, and they did move to places where they expected the pressure as a result of all this to be relatively low. So, so in the work that we're currently doing, we wanted to do a more formal analysis of the effects of this relocation on performance. And we took the same data that we had in the first paper, and now we wanted to do a analysis that controlled for the endogeneity or the self-selection between those that were relocating and the pressures that they were facing. And so what we found is that just simple some statistics, that about 15% of these facilities located across census tracts, and most of them were actually not moving that far. They were average moving distance was about 10 miles. In order to control for this causal effect of relocation on the toxic releases, we use something called the synthetic control method. And so, and I'll explain why we do that, but essentially what we do is we are creating a synthetic counterfactual form. For every firm that moved, we're creating a counterfactual firm that does not move. And then we can compare what the emissions are of the firm that moved compared to its synthetic counterfactual that does not relocate. And so this creation of these synthetic control firms is done through a process that assigns weights to the firms that do not locate, and optimally chooses the mix of characteristics of these forms that did not move to find a form that looks very similar to a form that moved. And then by looking at the difference between the form that moved and its synthetic control, we can then look at the treatment effect of moving. And other studies do other methods, similar, studies have to control for this endogeneity of this, the fact that the firms that relocated may have relocated because they wanted to change their emissions. And so we have to separate that out. You can do that in various ways. Most of the literature uses a method called the propensity score matching, which creates a likelihood of moving for different types of firms and matches a firm to another one that has a similar propensity but did not move, and so controls for that moving likelihood. But this synthetic control is a better method, allows for more flexibility in the assumptions about the error terms and how they can vary over time and so on. So essentially what we're after is to estimate this treatment effect. What are the emissions of the firm at location L1? What would its emissions have been if it had stayed on at location L0, which is the original location? And we don't observe emissions at L0 because the firm has already moved. And so that's the challenge we are overcoming here. And what we're interested in looking at is the extent to which, its emissions at after it moves is a function of the characteristics of the community in which it is relocating. And then, we assume that these characteristics are not affected by the relocation decisions for the same reason as we did in the first paper, because we're looking at values in 1990. So these possibly could not have changed before information became available. And so we need to identify this treatment effect, and we do that by using the synthetic control method. And the reason why it's important to do this is because it could be that facilities that were expecting to grow fast may be the ones that relocated. And we could, if we don't control for this, then it could be that we would attribute the change in emissions to the fact that they relocated rather than to the fact that they were going to be growing anyway. And they would have, no matter where they were, their emissions would have gone up. So, and so that's how that's why we need to control for this. And we do that with these synthetic facilities. So as I said, this treatment effect is going to depend upon those three types of variables. And we would expect that facilities that move to a location with weaker community pressure may experience a lower cost of polluting, and therefore they may generate more emissions than their counterfactual firm that does not move. So we'd expect that larger polluters with high pollution costs prior to relocation may be the ones which are more likely to increase their emissions. Also, facilities that may relocate because of lower regulatory pressure or better economic conditions, and this may lower the regulatory cost of pollution and the cost of labor and so on. So they may grow more because of better economic conditions, and with less regulatory pressure, they may pollute more. And so, we want to control for these differences in economic conditions and regulatory conditions when we do this analysis. So, and so we also looked at the effects of small versus large polluters, and, did the effects of community pressure differ for those that were larger versus smaller? There's various reasons why one might think that larger polluters are more likely to, rebuild their plants after they move, and they might implement pollution control technologies and reduce environmental liability. So it's quite possible that larger polluters may get cleaner after they move. Or it could be that if the community pressure is lower, they can, that might offset some of the incentives to clean up. So the point here is that it's a pretty complicated trying to tease out these various effects depending upon who's moving, why they're moving, which could be for various reasons, and what the conditions are at the two locations, the pre-move and post-move. So just a quick flavor of the results. In general, when we compare, so this shows we normalize all these forms to year zero, which is, on the x-axis is their move year. So year zero is the year in which a facility moves. And then the years with the negative numbers are prior to that many years prior to their move. And then the ones after are how many years we're tracking after they moved. So we're looking at, 11 years before to 9 years after the move. We're looking at their emission performance over that time period. And we find that for the solid line is showing the behavior of the movers, and the dashed line is showing the behavior of their synthetic control. That is their counterfactual if they had not moved. So before a year, up to 2 years, we find that the movers and the controls are actually very similar, which is what you would expect. Prior to moving, we've chosen these synthetic controls, we've designed them in a way that they match their, the movers. And so we find that in fact, the model that we've developed works reasonably well, and they're very similar. But after, year zero is when the movers differ from their synthetic controls, and you can see the movers are emitting more toxic releases than their synthetic controls. Although the emissions are kind of, in general, there's a bit of a downward decline, but nevertheless, there is a difference. But the graph on the right shows the difference between the solid line and the dashed line. And so it shows the difference, the treatment effect, the effects of relocating. And here we find that actually there's really not much of the difference is not statistically significant. So the difference between the movers and their controls is within the confidence interval, and it's not statistically significantly different from zero. So on average, the movers are not necessarily polluting more. But then when we separate these out based on the destination to which they're moving, so we separate out firms that are moving to lower income communities, to similar income communities, and to higher income communities. And there we find that really it is the facilities that are moving to lower income communities where the treatment effect is significant, is positive and significant. But for the other two types of communities, there is no difference in their behavior in terms of pollution levels. So that is sort of the indicator that the facilities moving, of this environmental injustice aspect, which is that those going to lower income communities are polluting more. If we look at, so this is sort of the regression which relates that treatment effect to various characteristics that I've discussed before. And we find that income levels and voter turnout levels moving to communities which is primarily democratic, all have an impact in terms of higher emissions. Moving to communities with lower democratic share but communities that are less politically active and lower income are the ones where the emissions after moving are higher than those in the counterfactual case. And so, which is consistent with what we would expect based on the hypothesis that there's likely to be incentives for such firms to increase emissions. So, okay, so essentially our findings show that relocation is associated with facility growth, and that is what leads to that increase in emissions. But the emissions per employee are not changing for relocating versus those who stay. So their firms are not relocating to become dirtier. They're relocating because they want to grow, and they choose to grow in places where labor costs and land costs are lower, and there's better access to railways and transportation and so on. But they do move, down the socioeconomic gradient also. So community pressures are one of the factors in addition to others that cause them to move, and they choose to move to places where that pressure is lower. And when they do that, although their emissions intensity does not change, but the fact that because they've grown, that can cause an increase in facility emissions. And in general, the relocation, like other firms, firms that are moving or not moving are tending to reduce their emissions. The toxic emissions are going down, but but the facilities that are moving to communities with lower income reduce their emissions by less. So, on average, facilities reduce emissions by about 15%. Facilities that move to lower income communities are only reducing them by about 7.6%, compared to a 62% or 63% reduction for facilities that are moving to high income communities. And so that is really, it's comparing different relocating facilities to each other. That, as I said in the beginning, is really the way to identify this and whether or not there's environmental injustice. And so this is really the cause of the heart of the results and the problem, which is that the facilities moving to communities with lower income reduce their emissions less relative to firms moving to communities with high income. And also those moving to less politically active communities also reduce their emissions less. And so that's the evidence that it's not just that there is relocation, but there's also, when they relocate, they're also changing their environmental performance in a way that is related to the characteristics of the community. So where is sort of, what does that mean? Well, what this shows is that environmental disclosure, programs can have this effect, not only on existing facilities, but also an anticipatory effect on facilities that expect to increase emissions in the future. And it can cause facilities that are moving with a desire to grow, to take into account the characteristics of their community and to change their behavior accordingly when they make that move. And so from a policy perspective, one has to weigh the benefits of providing information, because as I said, it did lead toxic releases to go down, but it also led to spatial redistribution of where those releases went down. And so it's clear that there's a need for providing more having more safeguards, sort of guardrails for that limit the ability of facilities to move without considering the environmental impact of their move. And so policymakers need to consider the side effect of information disclosure and look out for ways in which they can protect these vulnerable populations so that their concerns are heard. And there are some zoning laws and regulations that can prevent facilities from locating just based on where it's more advantageous for them without considering the impact of exposure and the populations to which they're causing that exposure. All right, so that's essentially my talk, and I'm happy to take questions.
Professor Sengupta, has his connection dropped?
Okay, so I think we should have him. Shrikant, do you want to fill in?
Yeah, definitely. So the floor is open, and I can already see two. Can I see any questions? Not yet, but I'm sure there will be lots of questions. Gaurav, would you like to call Ramprasad in the meantime, or you have his number, right? Or do you want me to, Aparna, do you want to start the questions? I'll just call him and see what happens.
I don't see any questions, but I wouldn't mind asking something which is on my mind. You actually...
So I'll mute myself and call him, because I was so engrossed listening that I forgot that he had dropped off. So.
Okay. So first thing that I wanted to ask of you is that you began by saying that it's going to be very different from the pollution heaven hypothesis, essentially because you're not looking at stringency. But when one thinks of the community pressure that can come from people with higher income, better education, that essentially would translate into some kind of a pressure whether it's moral suasion or it comes through the voting. So all of that essentially would mean that there would be a regulatory pressure eventually, if not immediately. So I wasn't sure why you wanted to qualify that this is really not in that realm. The second thing is when you are considering the counties and you're looking at drawing the, I think you said 1 mile across or around the circumference of the facility, and essentially you're looking at communities which are, I didn't quite follow the distinction that you made between what you call the census tract. Was that the county that you were referring to? Okay, so when you're thinking in terms of their movements across counties versus within counties, is there also a neighborhood pressure that can come, or a neighborhood effect that can come across the circumferences that you have drawn? So could it be that there is, and what would be your kind of answer in terms of that neighborhood effect if you were to control for that?
Great question. Yeah, thanks. And so you're right. I think, perhaps my, critique or need to distinguish from the pollution haven hypothesis was strong. And in part, I think I was in response to sort of reviewer comments on like, well, tell us how you're different from that literature. And so it was partly that. But so the main difference is that most of this pollution haven hypothesis has been across countries, and it's been in response to differences in regulatory stringency across these countries, and not found as much of an impact because environmental costs, it turns out, are a small proportion of overall costs for a firm. But ours is in that sense similar. We're also looking at pollution haven, although not havens from a regulatory perspective, although that is part of one of the things that we control for, but more in terms of community characteristics. And that does also, as you said, impose its own reputational costs and other reasons that translate into economic impacts for the firm. And so it does fit into that literature of pollution haven hypothesis. It's just a different way of how we're characterizing pollution havens and what type of costs we're looking for. But it certainly does fit into that squarely into that literature. And then with regards to the jurisdictions and how we're drawing it, so we chose like a 1 mile radius around every facility. Because there's other research which shows that the damages from the toxic releases are most felt within the 1 mile distance from that facility. That's sort of where you have the greatest negative impacts from health perspective. So we thought that communities within the 1 mile are most likely to be concerned about being located close to the toxic release facility. And we look at the characteristics because that 1 mile radius may span multiple census tracts. And essentially the census tract is the smallest tract for which demographic information is available in the US. So we take an average of the characteristics within that census tract as the proxy for the kind of pressure that the community is imposing. Now, some firms or facilities moved within so there could be many census tracts within a county, and some variables are only available across counties, like regulatory stringency is only known at the county level. So for facilities that moved across census tracts within the same county, we cannot determine whether that was the role of regulatory stringency, because there is no difference in regulatory stringency for those census tracts. And so some of our analysis is done for cross-county moves, and some of our analysis is done for cross-census tract moves. And the ones that are done for cross-census tract moves does not consider regulatory stringency, and others do. So that was the main point, that we could consider the effects of regulatory stringency for a subset of our firms that moved across counties. And when we do that, we do find that it plays a role, and firms do consider regulatory pressure when they're making those longer distance moves. So.
if you may permit me one follow-up
absolutely.
question I had. In the 90s, I mean, because some of my seniors were doing it at Columbia, they were looking at not the TRI, but they were looking at across counties or across states within the US, the relocation of plants. So how would you compare what was evident there in terms of the plants relocating kind of behavior versus what you see now with a much longer period being examined and with far more people?
I mean, there's been quite a bit of research that is looking at cross-county moves because of non-attainment status of the county, and also showing that non-attainment status comes with higher stringency, and so they are more likely to. Firstly, they are less likely to be places where firms locate to. And firms are more likely to want to locate out of those counties into other counties which are in status. So our results are very consistent with that literature in showing the same types of effects.
Gaurav, would you like me to read the question that I see in the chat box? There is only, yeah, I think I see one or two.
Please go ahead, Aparna, yes.
Okay, this is a question from Ramakrishna Nalla. Thanks, great presentation. Firms may make relocation decisions based on the availability of inputs of production and access according to urban/regional economic literature. Has that been factored into modeling firm relocation apart from the externalities effect, as well as other intervening variables like community characteristics and regulation? Access to markets, I mean, okay, yeah, access that he mentioned, access according to urban and regional literature was based, is essentially access to markets. So
yeah. So that, that's a really relevant point. And we did control for differences in access to input markets, mainly labor, because labor is a major driver of cost for a firm. And so we looked at wage rate in different counties, as well as the availability of employment rate. So if there's more unemployed labor, that's easier for firms to find workers. So we controlled for that. We also looked at access to transportation networks, and also whether there was sort of an agglomeration effect. And so firms might want to locate where there are other firms like them for other, there could be some economies of scale and other benefits of doing that. There could also be negative effects of locating where similar firms are located, because too many toxic releasing facilities may cause greater scrutiny. So we tried to control for those. We looked at land costs. So this was, what was the proxy for land costs was the cost of housing value or just housing values. And so those are places where we're more expensive to locate to. So we tried a number of these different factors that try to control for these input and output markets and economic conditions in order to make sure that it was not those factors that were kind of driving all of the relocation decision. And it was after that we found that these politically active and educated communities were more likely to be able to drive firms away from their communities.
I'm not sure I see any questions here.
Yeah,
okay,
so there is one.
Yeah, I just wanted to say I am here. I have my questions and comment.
Okay, so yeah, please go ahead, Professor Ramprasad. We have one question in the chat, and then after you ask your question.
How many questions are there in the chat still?
There's one that I have from Gayatri Kunde.
Okay.
You can tell me how to proceed.
Okay. So then should I first ask my question and comment?
Please.
Yeah, of course.
Okay. Thank you very much, Professor Khanna. Very lucid, insightful lecture, and what I really admire is your excellent clarity. You must be an excellent teacher and very clear conceptual framework. I would just like to, I cannot restrain myself from asking you a few questions. All of them may not immediately relevant to your paper, but since you are an expert here we get who has worked and thought so much about the disclosure. So I have a few questions relating to that and also about the toxic release issue. And, what kind of the damage it can create may have a much wider area, which is occurring to my mind. Now, let me just first say about the disclosure. Now, given your yesterday's talk and today's talk, now about this climate change area, this is, I want to be educated. What is the kind of disclosure? Because the greenhouse gas as such is not a toxic gas that which will kill us immediately, but it is in the long run toxic through its socio-economic and ecological impact. But that is a longer run toxic. But short run, it is not immediately toxic. But then what kind of disclosure would be helpful for us to do something for addressing the climate change issue? That is one. Should I give you the other questions, or you will take up one by one?
Let me take it one by one. Yeah. No, it's a great question. And so the thing is that greenhouse gas emissions are different from toxic releases, because toxic releases have a local health effect depending on where they are, and greenhouse gas emissions don't have a local effect. They affect the whole globe. No matter where the emissions are generated, they'll have an effect through their impact on the temperature. So, but the impact of climate change is local. Where climate change, where the effects of climate change in the form of weather-related disasters and sea level rise and those types of problems, pests and diseases and all that happen, that is a local effect. And so the injustice that arises there is on the which is the population that is going to be most affected when there's climate change related disasters. And so at least in the US, one major form that has been observed in in all urban and rural communities is increased intensity of storm events and rainfall related flash flooding and things like that. And the communities that are most affected are relatively the low income communities that are less prepared, that are in in locations where there greater, less infrastructure for stormwater management. And so those are the houses, and they are less likely to have flood insurance. And so providing information to those communities about, that can warn them before such events happen, or that can help to better prepare them to deal with these kind of impacts, I think is the type of solutions that are needed, which are different than what we're talking about here. But, but there's also injustice there in terms of their preparedness to deal with climate change related problems.
Thank you. I have the other question, that is, the kind of your discussion revolves around the toxic release, which is going to be affect human health and life. But the other question is, suppose I am concerned about the ecosystem's health, say marine life, or say coastal water. Water bodies, those who are living on aquaculture, and there the toxic release, if it is harmful for the aquatic species, and which may affect the livelihood of our who are dependent, whose livelihood depends on that. Now, for them, what should be our sense of justice? Suggest what can we take care of? This is one. Another is, think of the open ocean. The open ocean, in fact, this issue also was mentioned yesterday by Partha Gupta when he was giving his talk about the economics of biodiversity and all that. This open ocean, if that gets affected, deeply affected by toxic release, what would happen about the marine life? If they are dying one after another, it would be a huge problem for all of us in the humanity. The entire globe would be affected. So what is your thought about, can you tell us that how we should address these issues?
No, I think that's a great question. I think there has been some work looking at the effects of toxic releases on human mortality. I know there's a paper under review, but actually the first author of this paper, who was my doctoral work, she's co-authored a paper looking at the health impacts of toxic release inventory. But you're right that it could also obviously affect other species, and which now gives me a great idea for a follow-up paper looking at the effects on birds in particular, since we have done some work looking at what affects bird biodiversity, and climate change is one of the things that does, but there's local air pollution probably affects them as well. So I think clearly the solution is to try to reduce these toxic releases as much as possible. And that's the kind of thing that the voluntary programs are designed to do. The challenge with trying to, has been of trying to develop regulations to reduce these 600 chemicals that are emitted using sort of similar kind of command and control technologies, or regulations that tell firms what to do. But these are regulated in the sense that they're under the Clean Air Act. There's a regulation for hazardous air pollutants, and firms have to adopt these best available technologies to cut them down and so on. So efforts are being made, and in order to reduce them, but obviously more is better, and prevention is better than controlling them after they've been generated. So efforts, I think those need to be kind of those are important, and are being done. Now, whether they are sufficient and is sort of an open question that I don't have the answer to. It would be sort of interesting to actually do more work on whether, to what extent toxic releases are associated with higher rates of cancer, for example, and so on in certain locations. There's certainly a lot of anecdotal evidence about that. I don't know if there's been a lot of actual systematic analysis of that, but yeah.
I think that if some more research be done on the aquatic, the world, and these kinds of toxic release, or this hazardous waste release, put it in throw it into the open ocean. In fact, this is whether it is a nuclear experiment, when initially was being done. Now, from that down to many other our trials, experiments, or waste, get rid of the waste somehow, put near the ocean open, and do whatever you like. So this is something, now it is so reaching that is becoming a matter of concern. That is why I bothered him. Now, let me ask my last question.
Can I just jump in? Just if you permit me, I had something to add to what you were saying.
Please.
So no, thanks. Just a very quick comment was that long back when I was writing my dissertation on Superfund, and we were looking at choice of cleanup techniques, and Gaurav is nodding his head. So all this, and Ramprasad was mentioning hazardous waste. So what the paper that I had with Maureen, which was in RAND, was that we looked at zip codes And we tried to see if less thorough cleanup technologies were being used in areas where there were more blacks. So this was, and this suggestion, of course, came from Anand Swami, who was then a tenure track assistant professor at Maryland, and I was finishing up. So Anand said, why don't you look, so this whole idea of environmental justice, now I don't want to sound like this old man, oh, I started it all, but this idea of environmental justice as far as Superfund cleanups is concerned. So for those of you who perhaps don't know, Superfund is a program of the US EPA to clean up these abandoned toxic waste sites, Love Canal and those sorts of places. So what we did was something quite simple. It was a kind of an extension of the work, and it's in the paper. And so it's not exactly what you have done right now, but we looked at the location of our Superfund cleanup sites. And since I had very little resources, I just took zip codes. So I didn't use census tracts, and we looked at the percentage of minorities. And we did find, actually, other things equal, that less thorough cleanups or more perfunctory cleanup technologies were being used. We had a multinomial logit model. So it's kind of nice. I'm not making a plug for my work, but I'm saying that, it was a very interesting thing. And then, as you know, Madhu, a lot of literature has come on environmental justice. In the Hilary Sigmund and those sorts of people have done a lot of work. So I think that was kind of the precursor of some of the things that you were talking. But very quickly, just one point, which is, I think, very interesting, what Ramprasad said, that, there is a carbon disclosure project, which is an international project. So Ramprasad, you know this, it's an NGO where companies can sign up, Fortune 500 companies can sign up for the reason of good citizenship and CSR, the kind that Madhu was talking yesterday. And they disclose their carbon footprint. And the last thing is, because a lot of young scholars are here, so an idea for research is that now we are hearing a lot of net zero. Net zero has become this buzzword has come. Now, so for example, my own cousin, who's the president of Coca-Cola in India, told me that his company has now become net zero. So the idea is that, this whole idea of net zero at the corporate level, I think there must be very good data and a very interesting paper being waiting to be written on this. So it connects to what Ramprasad said about disclosure and climate change and the CDP. So I think there is a lot of potential to do this. Now the question is, which of us is going to write that paper first? So
yeah, one of the challenges is that with the carbon disclosure project is that you only have data for the firms that decide to disclose. So there's self-selection there, and it doesn't allow you to compare. I mean, the whole question is, what would firms have done anyway if they had not participated? What is the additional that they're doing? And to what extent, because I don't know to what extent the carbon disclosure project is, requiring all types of emissions to be reported, and so there's it certainly is, I think, work worth doing into looking at what the carbon disclosure project is requiring firms to do, who's reporting. And then I would imagine that data is available, at least even understanding, even though it may not be econometrically done in the most rigorous way, I think is worth looking into to see, because from what I have seen, although it's like you have actually a segment in India, there's a carbon disclosure report for India that is generated. And in many different countries that can be looked at, but it's the number of firms that are participating is still small, and the amount of reduction is, I believe, it's been growing up, similar to what we find that even though the intensity may not go up, but because firms are growing, their emissions are growing. So so how are they defining net zero? Is that net zero conditional on size? Is that overall net zero, no matter what the size is, they're going to be becoming net zero? You know, I think there's lots of interesting stuff there to be dug into, and it could make a great project. So certainly encourage people to look into it. Yeah.
There were some more questions that you needed, that you were intending to read out.
I've just last one small question. That is about Professor Khanna, you have indicated about the use of the synthetic control and I think propensity score matching to find out the impact of your on the relocation. Am I right?
Yes.
Propensity score matching. But the other thing that there would have taken certain movement, possibly relocation, for other secular factors, which is not immediately linked with this. Now, for that, you require again another control, that is, you take either two different period or two different area, so that then you take the difference of difference. Possibly, even if I'm confusing, the double difference will then take you the neat impact of just the factor whose impact you were trying to trace. Am I correct? Have you addressed that also, the second difference?
No, that's a great point too. I mean, the synthetic control, so the challenge with the propensity score matching, so the ideal way to do this would have been to do this, you know, an instrumental variable, panel data with instrumental variables. We have an instrument for relocation that is not related to emissions, and that would be the best way to do this. The problem is finding those instruments that are, and so methods like the propensity score is one way to, you know, do it, except that it is assuming that there are no time varying factors that are correlated with the decision to with the emissions, and so it has certain limitations. The synthetic control method is somewhat better than the propensity score method, but that also is not, you know, has some limitations on the assumptions it's making on the error term. So so this is sort of you know, looking at what is the best possible given the available data and trying to, you know, between the Ubers and the
very much. No, thank you very much. In fact, otherwise, I greatly appreciate your paper and effort. I would have a hurried look reading on the paper which was sent to me.
Yeah. Oh, thanks for your comment.
So,
and now, if there is Aparna, you know, you are saying that some other questions might have been there in the box. So if you
yes, Gaurav will read it just now. I don't have access to that.
Yeah, okay. There's one question that has come to me. It has come from
Professor Khanna.
Yeah, sure. So, so it has come from Gayatri Kunte of Christ University, Bangalore. She says, "Thank you, Professor Madhu, for your insights. Just a question on the cost of pollution and its impact. If we are looking at the social cost of pollution, would a successful government tax structure that could impose penalties on pollution firms or polluting firms prevent relocation?"
Yes, I mean, we know that the best, you know, most efficient policy really would be to tax these firms for based on their toxic releases, and if those, and so, you know, that could limit, create incentives to reduce emissions, and where they currently are, it would limit incentives to move because they would still have to pay that tax no matter where they move to. The main challenge is, you know, getting these kind of tax legislations passed. In the US, there is no example at all of any kind of a Pigouvian tax on pollution being implemented over the last 60 years or so since the EPA has been in existence, and including, you know, a carbon tax or anything. And so and that is why there is all this reliance on voluntary programs to get these firms to start to do something, because getting tax legislation passed can be many year long process. And so in the short run, there's really, this is one way to create incentives, which is why you have these information disclosure programs, but then you create these perverse incentives for them to move. And so there's a little bit of a catch-22 problem here, but yeah, but great question. Yeah.
Okay, Aparna and Srikanth, if there are no other questions, should we close the session now here? It's up to you.
Yes, Ramprasada, we can do that. It's 1
Yeah,
o'clock. So
we are just on time, and I again think that we're a lot of young students here. So Madhu, this is a rare thing, for us to hear, like a frontline scholar like you sitting in the comfort of our own. Well, I'm here in the IIITD Delhi meeting hall, but so I think it's really inspiring, I must say, and if you may permit me, since we go back to D school, that to see the kind of the way that you have done all this research and all your collaborations, it's truly inspiring. And I really think, I hope that all the younger INSEE scholars, take inspiration from this. And it's been wonderful. The two lectures that you have given us to INSEE, I think we are very grateful. Gaurav, these will be available now on the thing, the YouTube or whatever.
Yes, we have been recording all plenary lectures.
Yes.
So that's the plan. Although we'll do it after some sort of after this.
Yeah, and the background readings are there. The paper that because Madhu combined two papers, the one that's published and the one that's forthcoming, and then of course the papers that were discussed. Yes, they're all on our website. And I think it is a very important area, Madhu, because when we thought of this session, we were thinking, okay, there is those two poles, command and control, market based, but your whole body of work of voluntary abatement, community pressure, CSR, that kind of middle ground is what I think is what you have highlighted for us. One area that I think where you and others of us can work is, see, India is unique with the judiciary and the whole PIL and the judiciary, right. Supreme Court, High Court, so for me, if I'm a citizen activist, community pressure largely also comes by going to the courts and so, so the whole, I think that's a very, very fascinating area which has been totally untouched by economists. So the whole idea of that, I think, would be a very rich area for you. And of course, you're now an INSEE Life member, so you're a part of our community, and so is Sangeeta, your co-author on this in some of the earlier work that you were mentioning. So I don't know how I got into this situation, but yes. I think Aparna, you may want to just close the session formally since you started it.
So I would like to thank Professor Khanna and Professor Sengupta for generously giving their time and being very, very lucid and patient with the questions that were addressed. And as Ramprasada correctly said, that you're a very good teacher. So as you go along talking about it, one gets a feel that one is literally sitting in the classroom. So that was a great feel. Thank you so much. And yes, I second